In this video, we're going to talk about pulleys, but we're going to build upon our knowledge of pulleys a little bit and use it with another force that we've talked about before in class, and that's the frictional force. And so let's read this problem. It says, using the diagram below, find the acceleration of the system and the tension in the rope. And the coefficient of friction is 0.2. So the place that we always start in a physics problem is to draw the free body diagram. So we see here there's a mass on one side of the pulley that's sitting on a table, and on the other side of this pulley there's a 4 kilogram mass that's hanging directly below the pulley. And so if we draw all the forces, maybe let's start on this mass here. We know that it's hanging, so there's a force of gravity here, and that's equal to mg. And so if you take 4 and times that by 9.8, you're getting 39.2. So that's equal to 39.2 newtons. Okay, and we know that it's hanging from this rope, so we call that force the tension force. So I'm just going to designate that with a capital T. And that's all the forces that are acting on this mass. There's no forces left and right, so it's just hanging here. Let's see what the forces are on this other mass. It's sitting on a table, so we know that there's a force of gravity. And 12 times 9.8 is equal to 117.6. So 117.6 newtons. And it's sitting on the table. It's not accelerating in this up and down direction, so we know that the force that's up, which is the normal force, if the object is not moving, the forces have to be balanced. So the normal force in this case will be equal to 117.6 newtons. Okay, and there's a rope here, so we're going to call that force tension. And there's also another force acting on this block, and it's acting in this leftward direction, and we're going to call that the force of friction. And if you remember back from our previous videos, the force of friction is equal to this coefficient of friction times the normal force. And it told us in the problem that the coefficient of friction was 0.2. So I'm going to take the normal force, 117.6, times that by 0.2, and I'm getting 23.5. So this force is equal to 23.5 newtons. Okay, and so right now we filled in our free body diagram of all the different forces that we can as far as right now. And when we get to this point, it's important to look at two forces. One of the forces is going to be this force of gravity hanging from this mass, and the other force is going to be the force of friction that is experienced by this mass. And what you want to do with these two forces is to compare them and see which one is larger. In this case, the 39.2 newtons is larger, and so what that means is there's going to be a net force, and this block is going to be moved down by gravity, and since it's connected by a rope to this block, it is also going to move. So let's draw in our direction of motion. And so acceleration is positive in this direction. So everything to the right is positive, and everything down will be positive. Okay? And so the question wanted us to find the acceleration in the system. Whenever you see the word acceleration, you should think force net is equal to ma. And we're going to use Newton's second law to solve this problem. But our one issue is that we have two unknowns. We don't know what tension is, and we don't know what acceleration is. And the only way to solve a problem when you have two variables that you don't know is to use two equations. And so that's what we're going to do. We're going to use those two equations again. We're going to set this up so our net force is equal to ma. We're going to set up two equations. On the first equation, I'm going to go off of this part of our problem over here. We're going to use this block, and we said everything to the right was positive, so tension in this case is going to be positive. So tension is positive, and everything to the left will be negative. So we're going to subtract off, to get the net force, we're going to have to subtract off everything to the left, which was that force of friction, 23.5. And that'll give us the net force here. Remember, up and down they were balanced. And that's going to be equal to, the mass of that object was 12 kilograms, times the acceleration, and we don't know acceleration, and we don't know tension. Okay, for our other equation here, we're going to look at this part of our problem and determine the net forces acting on this block. So we said that down was positive, so this 39.2 is going to be positive, and I'm going to subtract off, to get the net force, we subtract off tension. So minus tension, and that's going to be equal to the mass, which was 4 kgs, times the acceleration. And when we take those two equations, we're going to want to add them together. And when we do that, we'll see a positive tension here, and a negative tension will cancel out. Your tension should always cancel out. If they don't, you've done something wrong in the problem. Look at your sign notation. Go back and look at it and see if you've got everything straight there. Okay, so on the left side of this equation, we've got a positive 39.2 and a negative 23.5. So what I'm going to do is take 39.2 and subtract 23.5. And that will be 15.7. And that's going to be equal to 12a plus 4a. 12 plus 4 is 16 times a. And so to isolate a, you divide both sides of this equation by 16. And when you do that, you're going to find that acceleration is equal to, by 16. So acceleration will be equal to 0.98. And acceleration, remember, is always measured in meters per second squared. And so there's your answer for acceleration. But it also asked us what's the tension in the rope. To find tension, again, like we did in the previous pulley problems, we just take this acceleration value that we found and we can plug it back into either one of our equations here. I always choose the one where tension is positive. It makes it a little bit easier. So what we'll do is we'll take 12 and times it by 0.98. So 12 times 0.98, and that is equal to 11.76. And then we have the rest of our equation is tension minus 23.5. And so to get tension by itself here, we're going to add 23.5 to each side. So plus 23.5. And I'm finding that tension is equal to 35.3 newtons. And so there's our answer for tension. So yeah, that's a good problem to work through. I've got another one real quickly to show you. There's a case where you might not see any motion at all. And so let's look at something like that. This one says, use the diagram below, find the acceleration of the system and the tension in the rope. The coefficient, again, of friction is 0.2. And so I'm going to work this problem a little bit faster. We've got the force of gravity down here. We've got tension up. And if you find the force of gravity, that will be 12 times 9.8. And so this force of gravity is going to be equal to 117.6 newtons. We don't know tension yet. We can find the force of gravity here. 75 times 9.8 is equal to 735 newtons. And if that's the force of gravity, we know that it's not accelerating up and down, so the normal force has got to be equal, but opposite to that, so 735 newtons. And we know that we're going to have a force of friction here. And again, that's equal to the coefficient of friction times the normal force. And it told us in the problem that the coefficient of friction was 0.2. So when you take 735 times it by 0.2, I get it that it's 147 newtons. Okay. And when we get to this point, again, we want to compare these two forces, the force of gravity on this block and the force of friction on this block. In this case, we notice that the force of friction is 147 newtons. It's larger than the force of gravity on this block. So what that means is the force of gravity here is not strong enough to overcome the frictional forces that are felt between the block and the table. And so you're not going to see any motion at all. And so this one makes it a little bit easier. If you're not going to see any motion, the acceleration is 0 meters per second squared. And if your acceleration is 0, that means this block here is going to be at rest. So to find the tension in the rope, we will simply take the force of gravity down, which is 117. And if this block is at rest, remember Newton's first law, if an object is at rest, the forces acting on it have to be balanced. So the force of tension here is going to be equal to 117.6 newtons as well. And this block up here is not contributing to the tension. It's not giving any, it's not adding to any tension that's felt in this rope. The only block that's adding tension to the rope is the one hanging here from gravity. And so the tension in this rope is equal to 117.6 newtons. And so that's just gives you an idea of how to find tension if the force of friction here is larger than the force of gravity here, and the system is not experiencing any acceleration. So anyway, I hope that helps. I have a couple of problems for you for your video physics. There's two problems that will follow. Remember, if you get a little bit confused, go back through the video. If not, come talk to me. You're welcome anytime. We'll work it and solve it together. So good luck.